This talk is more of an experimentation of the different things that we could do with RxJS and certain practices and designs that we could use to make usage when you need to use RxJS much easier than what it usually is for people. It's pretty painful getting into it, and it doesn't need to be. So we're going to explore some concepts that we could use to make that a much more pleasant experience. So I'm going to try to explain kind of some RxJS features as I go along, but if I started going off the deep end, just let me know, and I'll back it up a little bit. Okay, with that started, I'd like to walk you through the progress of a typical app that uses a hello world app, and then you have to add some functionality, and you keep building complexity. And as you build complexity, your app kind of gets a little hard to follow and hard to develop, and testing gets more complex, and you have to do pretty complex things. So the typical use case would be you would have a function. Very simple function, takes an argument, does something to it. One day, you start using Angular, and Angular doesn't really have values. They use observables all over the place. So if you needed to do that, you would need to create a pipeline. Now, a pipeline is, a pipeline is you build up the operations that you want to handle, and it doesn't really execute until you subscribe to it. And generally, you could do that by calling the subscribe method on the observable, or you could use an async pipe in a template, which is generally the preferred way of doing things. So far, it's pretty simple to use an observable in place of a regular value. You just subscribe to it, map over something, and then apply the function. But let's see if we could do something better, because this doesn't really scale. And what we're going to do is we're going to put the function on the top of the pipeline. And that's going to be a little weird, but we'll see where that leads us to. So the first thing we do is we wrap the function in just the plain of. This just creates a pipeline of a value. And then what we're going to do is we're going to pluck the value that we want. So in this case, this is an observable of string. So with latest from is an operator, and Rx is built around operators and manipulating pipelines. What this does is it takes our function and it combines it with the value that we need. And we know those two go together, so then when we can map them over them, and we could apply the function to the value. So far, nothing crazy happened. This is kind of the most bizarre thing that a lot of people have seen, but that's pretty straightforward. This works for a single argument, but let's see what happens with multiple arguments. With multiple arguments, so we're going to create a function that takes two things, a string and then a number, and it just does some processing. It can make an API call. It could render something or whatever the function wants to do. And now we're going to now the problem is we have observable values instead of plain old values. So now we have to create a pipeline to be able to use this. What we're going to do is we're going to start the pipeline, then we're going to pluck the first value, and that's going to give us a pipeline of the function and the string. And then we're going to, with latest from, the next one, and what that's going to do is that's going to take our original tuple of function string and give us a tuple of that with a number. Okay, so far, there's a lot of things that we're holding on to. And then we're going to use some fancy destructuring to get all those in one place, and we're going to apply them. And if we do this, we should get the value. And that's what we're looking for. But this is somewhat unwieldy, because imagine you had 5 arguments. You would have a pretty gnarly looking tuple when you destructure it. So let's see if we can improve that design. So what we're going to do is we're going to curry the function. Now, a quick crash course in currying, if you're not familiar with it. Currying is when you take a function that takes, in our case, 2 arguments, and instead we're going to create functions along the way that only take the next value that we need. So in our case, The original thing is a function that takes a string and a number, and it returns a string. And what we're going to do is we're going to have a function which returns a function which takes a number and it returns a string. So the previous usage would be you just call it with 2 arguments. Now you call it with an argument, and then you call that with the next argument. And that's kind of how currying works. So how does this help us? So let's see. What we're going to do is we're going to curry the function and then wrap it in an observable. And now what we're going to do is we're going to pull the argument that we need, which in our case is a string. So now we have a tuple of a function which is expecting a string argument and the string argument. And now we're just going to connect those 2 things together. And what this is going to return, this is going to return a function that expects a number and is going to return our final result. So we're going to grab that number value, and then we're going to apply it over here. And if we do this, and everything works right, we get the curried pipeline working. So one thing in Rx that is very helpful to do is to look for patterns. And when you see a pattern, that's usually a sign that you could create an operator. An operator is something like this is an operator, with latest from an operator, maps an operator. We can create our own custom operators. The syntax is a little hairy, and we're not going to focus too much on that, but we're going to see how these 2 calls are repeated twice. We do it with latest from and then a map, and then we do it with latest from and a map. And we do that however many arguments we have. So we're just reaching in, grabbing an argument, throwing into our curried function. If we get a curried function back, we reach in again to get an argument, and we apply it to the function. So we're going to take that pattern, and we're going to turn it into an operator. And we're going. Yes.
Better, bigger, smaller, bigger. Yes.
Bigger?
One more.
Okay, we're running out of space over here. Okay, let me actually collapse that. We don't need that. Oop. Okay. That's really big. Now I have to remember what my screen contents are. Okay. So we're going to create an operator out of this combination of calling with latest from and map. All right, so just to recap, we have a pipeline of a function that takes an argument of type string, let's say. We're going to turn that into a pipeline. We're going to with latest from that string as an observable. So we're going to get a tuple of function and string. Function that takes a string, and then we just apply those 2 together. So we're going to call this operator with latest from map. We're going to work on the naming. That's not final. The implementation's not important, but the important thing is that we call our function pipeline. We call with latest from with the argument, and then we just apply those 2 together. And now we're going to see what we did before, and we're going to use this operator to make that work. And this is what it looks like. We have our function. We have with latest from map item and with latest from cost. Now, if you squint, this is almost identical to the original usage of just a plain function that takes 2 values and you just send it 2 arguments. This is what we're doing. We have a function. We have 1 argument and the second argument. And calling this sends it right there. And this is kind of the base, the main idea of what we're trying to accomplish here. We're going to use this concept of creating the curried function with values and putting them together, and we're going to see exactly how far this concept can go. Okay. So the first thing we're going to do is we're going to call it apply, because with latest from map is pretty wordy and not really telling us what we're doing, it's just telling us how we're doing something. And this is literally copy paste of the same thing. I could have just called it, set the value to the other thing. And this is pretty much how we use it. So now same thing, instead of with latest from, we're just using apply. But this actually looks like what you're trying to do. You have a function, you apply an argument, and then you apply another argument, and then you get the value. And this should be the same value, and it is. Okay, so I work on Firebase in the console product, and part of that is there are different projects, and the different projects have different project numbers, and we kind of use that to get the different values that we need from the API for the list of apps that you have, or the different databases, or cloud messaging campaigns, or things like that. So that's a very common thing, and generally what we used to do is we used to just pull that directly from the router or something like that. And then we kind of moved towards a more observable way of doing that. And all those functions that took a number now need to take an observable. And you have to start creating pipelines, and that gets complicated and doesn't need to be. And so we're going to look at kind of what that transition looked like. So over here, we're just going to create a fake user and a function that gets a project number and an API call to save a user for authentication, let's say. So in your component, you would have an onClick event, and all that would do is just make that API call. And as I said, now our project number is an observable. So using what we just saw before, here's how we would do it. We would query the function, and we could just use the $value because that's an observable pipeline of a function. And then we just apply those things one at a time. And as we do that, we should get the call to do that, and that works. And now I want to just call out one more time just how similar these two pieces of code are. So this is the original code. API call, function, argument, that's it. Over here, we have API call as an observable, which is also queried. Apply the argument and apply the argument. We have to actually subscribe to it, but if we're going to use Angular, we're going to use async pipe or something. We may take until this on destroy and then subscribe to it, or something like that. Take one if it's an API call. We don't want that to keep happening. Things like that. That's more implementation detail of Rx than the actual usage of how this pipeline works. Okay, one thing that seems somewhat annoying is that I turned both arguments into an observable, but I kind of didn't mention that case. I just told you the case of where just the project number is an observable. So there are kind of two ways to deal with that situation. One is to just wrap the value in an of and just turn it straight into an observable. The other is to just create another operator called applyPlain, which does the same exact thing as apply does, but it works on a value instead of an observable value. So that's pretty similar. Over here, instead of the parameter being a observable of the param, it's just the value itself. Then we just pipe that right in. This is much simpler than the other usage. Okay, and this is just a usage of that working. Okay, now that's pretty cool, but it isn't really that much better than just combine later stuff, the arguments, and then just mapping those and just calling the function with whatever you collected. So let's see how we could use this for more powerful designs. So in NGRX, I'm going to create just set the stage for NGRX. There's quite a bit of boilerplate in NGRX, so let's get that out of the way. So over here, we're going to have a user state, a setting state, a global state, which has both of those. Then we have a Mockstore, which has that global state with some values. And then we're going to have two feature selectors. And this is just NGRX. For folks who aren't familiar with NGRX, it is the Redux pattern interpreted through Angular. And you're going to have you have a store, and you have selectors and actions and reducers and all that. The important thing that we're going to focus on is selectors. So selectors are a way to get this global store and to pluck out values from that global store as we need them. So there's something called a parameterized selector. What a parameterized selector is when you have a value that you need in order to create the selector. So for example, if you had a project ID and you needed to look into a global dictionary that had project ID to some state, you would create a function that takes this ID and then it returns a selector based on that ID. And it would look up, in this case, using up the user ID based on this record type. Okay, so the typical case, you would have a user ID 1, and then we would just create a Mockstore. Mockstore is a behavior subject, so it always has a value, usually the initial value if you didn't actually do any actions on it yet. So you could always get something from it. So over here, we're just going to, we're invoking this parameterized selector with a value, which is going to return, everything I've highlighted here returns a selector, and then the store gets selected with that selector that it returns. It's a lot of steps there, but this is a popular paradigm to get something from the store that you don't know ahead of time everything that you need in order to get it. So this is a simple usage. This is just getting me from the store. And now, to throw a wrench in everything, the user ID is now going to turn to an observable. Now, a lot of people are thinking that if it's an observable, you can create a selector that just takes multiple things from the store and just grabs it. So, which is a valid way of doing it, but if you were using reactive forms, the value of the form is also an observable. That has nothing to do with the store, and you can't really pipe it into there. So you'd have to get the store value and get the value from the form control, put those two together, then do the selection in there. It gets pretty tricky. But based on what we just saw, we could create another function that's going to help us in figuring out how to solve this. So over here, this is what we can't do. We can't just use a observable for that. We would have to use the observable, subscribe to it or pipe to it, and then return that, and then put that back into the pipe. It's not fun. Instead, what we're going to do is we're going to create a select dollar. Now, what select dollar is going to superpower our selectors to work with observable parameters. So the implementation is not too important, but the general idea is that we take a function and we take our state and we just put those two together in a specific way. We'll see how this is used in a second. So over here, we created a selector that works with observable parameters. Now, everything I have highlighted over here is exactly the same as the getUser selector. In fact, I could just have done of getUser, and it's the same thing. And what we're going to do is we're going to select from the store using this fancy operator that we just created. We are going to apply our argument to that powerful selector. And if we do that, we get our value. Okay, so this is very hard to do without having some form of control like this. Okay, so this is RxJS using this thing. This is combining functions with values. We're going to see this isn't limited to RxJS. We could use this with other things also. What was that? I thought I saw flickering. Oh. Right. I just won't move. Okay. So this concept of wrapping a function and then doing some fancy operations on it to be able to use other values that are also wrapped in that type of container doesn't just apply to observables. We're going to see how we could use that in other cases. So a very similar thing to observables is promises. And this works just as well with promises. How that's going to work is, imagine we have an item promise and a price promise. What we could do is we can query the function and then wrap it in a promise.resolve. Now promise.resolve is promise version of observable.of. It just takes a value and just wraps it in a promise. And you can call .then on it, and then you get it would be that function that you passed to .then would get sent into that function. So what we're going to do is we are going to take our function over here, and then we're going to return a promise.all of our function and the next parameter in that pipeline. And then we're going to collect those two together, and we're going to invoke the function with that value. Now that's going to return us a promise of the next iteration, the next step in the curried function pipeline. Pipeline's not the right word, but okay. And what we're going to do, now we have a function that is expecting a number promise, or expecting a number. What we're going to do is we're going to promise.all that value and the number promise. And that's going to give us the function that expects a number and a number. And then we're going to apply those two. And if we were to make this happen, we get all that executed. Now, with promises, we could kind of do the same thing, which create an operator. It's not as common with promises, but there's nothing stopping us from doing it. And what we're going to do is we're going to just call it apply then. Implementation is not important, but we could just squint and we see we're calling promise.all on a function and a value, and then we just invoke it. And this looks exactly the same. We call promise.resolve on the curried function. Then we apply, we call .then. .then is like instead of pipe, we just use that. And then we apply then for the argument that the curried function is expecting. And we do that for each argument that the curried function is expecting. And this should give us the exact same result. There you go. But wait, there's more. It isn't limited to observables or to promises. We could use it with any container type that wraps other values. The most famous container type that everyone uses day to day is arrays. And what that's going to look like, we're going to, so I had to use a different stack list because I couldn't get like TypeScript to work in the same thing, but it should have gone in the same place. Don't pay attention to that aspect of it. So what this is going to do is we're going to create a curried process stuff, and we're just handwriting the curried function now, but it's the same thing as calling curried on the original function. And what we're going to do is we're going to have multiple values that we want to apply with this. So here's some items, here's some costs or some prices, and what we're going to do is we're going to call flatmap. Flatmap is the array version of then for promises and the pipe for observables. They're all in the same, they all accomplish the same task, which is they could take an observable and return observables and kind of make those work together, or in promises that return promises and make them work. Flatmap is arrays that return arrays, subarrays, and they just flatten them together. They all accomplish the same thing. So what we're going to do is we're going to take our function, we're going to call items.map on that, and then invoke the function for each of those things. So that's going to return an array of curried functions. Okay, but we know how to deal with that. Then we're going to have an array of curried functions. We're going to flat map that over the next part of the pipeline. And if we do that, we get all of our, oh, that doesn't format very well. We get all of our things formatted. But we could create another version of an operator. And what that is, the implementation is not, the TypeScript is a little tricky, but the implementation is the fact that we just take the parameter array, we map over it, and then invoke each function on each value. And this looks exactly like the code we had before. We call flatmap, apply array of the items, and now we have the next part that the function is expecting is a number, and then we do that with a number, and we should get the same thing. Okay, this paradigm works for any value that has flattening abilities. There's a certain name for this type of design. It's not important, but anytime that you have that concept, and this applies for optionals in Swift or tasks in some language that do some concurrency processing or something like that. In fact, over here, we have an optional class. An optional has a map, a flat, which is like array.flat, and a flat map. And it has an of, because we'll make it look like Rx, because Rx is like the closest to the proper API design for this. And we could do the same thing. We could have an optional it's not pretty common in JavaScript, but in something like Swift, it's a thing that either has a value, has one value or no value. It's called maybe in some other languages. In Swift, it's called optional. I don't know what it's called in Kotlin, but they have the same thing. So what we could do over here is we could wrap our function, curify our function, wrap it in an of, and then just flat map each item. This is exactly like an array. And if we do that, we should get the same thing. And one more time, because we're creating operators of everything that we do, we create an operator, and this looks exactly like the array operator. The only difference is this is called optional instead of array. And we can do the same exact thing. Did that work? It's supposed to work. But that's all right. Pretend it works. This is what I wanted to show you, which is what I'm experimenting with right now. I don't really know, kind of playing around with it, seeing what I think about it, how it feels, what other people think about it, and kind of potentially get the operator into Rx itself, the apply operator, and hopefully have the pattern become more popular, because it does simplify a lot of times when you have application that expects non-observable values, and then you just throw observable values in it. It doesn't need to be complex, and it doesn't need to be a hard thing to do. It should just throw apply at it, and it should work. And yeah, that's it for my talk.